Imagine something is stirring beneath Pluto's icy shell, something ancient, hidden, and possibly alive. When NASA's New Horizons spacecraft flew past Pluto in 2015, scientists expected to see a frozen, dead world. Instead, they discovered something that shook the scientific community. Beneath the surface lies a vast ocean. Not a frozen sea, but a deep, liquid body of water moving quietly under miles of ice. This ocean is so powerful, it has cracked Pluto's crust and carved scars across its entire surface. And now, scientists believe that what lies in that ocean could be waking up. Pluto was never supposed to be special. For decades, it was just a distant icy rock at the edge of the solar system. Cold, small, and forgotten. It was even kicked out of the Planet Club and labeled a dwarf planet. Most scientists assumed it was a simple ball of frozen rock, drifting in the dark. But everything changed when New Horizons flew past it. What that small spacecraft found stunned everyone, and turned Pluto from an afterthought into one of the most mysterious worlds we've ever seen. As New Horizons zoomed past Pluto, it sent back images that showed something strange. Pluto wasn't just an icy rock. It had jagged mountains, deep valleys, huge cracks, even signs that something might be moving beneath its frozen surface. Those clues all pointed to one thing. Pluto could have a real, active ocean deep underground. And that's huge. Because where there's water, there might be life. The idea that Pluto, a tiny frozen world so far from the sun, could have liquid water shocked everyone. But the evidence kept growing. Pluto's surface is covered in nitrogen ice. In some places, that icy layer is just a few inches thick. In others, it stretches down for miles. Beneath that top layer is a thick shell of hard water ice. But here's the twist. Under that shell, scientists now believe, is a massive planet-wide ocean of liquid water. This changes everything we thought we knew about cold, outer worlds. But how is this possible? Pluto is nearly 40 times farther from the sun than Earth. Its surface temperatures hover around -382 degrees Fahrenheit. Water should be frozen solid. So how can Pluto have a liquid ocean? The answer may come from deep inside the planet. Scientists believe Pluto has a rocky core. And if that core contains radioactive elements, just like Earth's, they would slowly give off heat. Over billions of years, that heat could rise through the rocky layers and melt the bottom of the icy shell, forming an ocean. It would sit roughly 100 miles below the surface. Still completely hidden. Still completely alien. But very real. And possibly still liquid today. But how do we know it's really there? Scientists looked for physical signs. When planets spin, they tend to bulge around the middle. Like a soft ball squeezed at both ends. Pluto probably spun faster in the past. If it had a liquid ocean beneath its ice, the outer shell would be able to shift over time. That bulge would slowly smooth out. But if Pluto was frozen solid, that bulge would remain. So, scientists carefully studied images from New Horizons. These pictures were incredibly detailed, showing surface features as small as 200 feet. They looked for signs of that bulge, but instead they found something much more alarming. Pluto's surface is full of massive cracks, gashes that stretch across huge distances. These aren't normal. They didn't come from asteroids or space collisions. They came from inside Pluto. The cracks suggest the planet is expanding, that something beneath the ice is pushing upward. If Pluto's ocean started to freeze, it would expand. Water takes up more space when it freezes. That expansion would put pressure on the ice above, cracking it open. And that's exactly what New Horizons showed us. Pluto isn't quiet. It's under stress. It's groaning under its own frozen shell. One crack stands out the most. It starts near the North Pole, cuts through the middle of the planet, and curves down toward the south. It's enormous, ancient. A deep scar that stretches across continents. This isn't a riverbed or a valley. It's evidence of violent, internal change. A massive rupture caused by something deep, cold, and powerful. That force might still be there. Might still be active. Imagine the frozen heart of Pluto slowly beating, pushing, cracking, trying to break free. That's not just science fiction. It might be reality. One of the most mysterious features on Pluto is called Sputnik Planitia. It's a massive heart-shaped basin made of frozen nitrogen. At first glance, it looks calm, like a peaceful, icy lake. But its location is suspicious. It sits almost exactly opposite Pluto's largest moon, Charon. That might sound like coincidence, but scientists calculated there's only a 5% chance it happened by luck. So what caused it? The best explanation is this. Billions of years ago, something huge slammed into Pluto. A space rock. The impact carved out a massive crater. And from deep inside Pluto, something responded. Scientists believe the impact pierced through Pluto's icy shell and disturbed the hidden ocean. Liquid water rushed up and filled the crater. Later, that water froze and nitrogen ice piled on top. The basin became extremely heavy. That weight changed Pluto's balance. It shifted the entire planet so that Sputnik Planitia lined up opposite Charon. This kind of movement is called true polar wander. It can only happen if the planet's outer shell can move, and that only works if there's a liquid layer underneath. Once again, Pluto's strange behavior points to a hidden ocean. Even the far side of Pluto shows signs of mystery. While New Horizons only captured blurry images of that region, what it revealed was surprising. The ground there looks broken, twisted, as if the crust itself was shattered like glass. Scientists call this chaotic terrain. Ridges and blocks don't line up anymore. It looks like a puzzle with pieces forced into the wrong spots. What? The theory is simple. When that massive impact created Sputnik Planitia, it didn't just dent the near side. The shock waves traveled through Pluto's interior and smashed into the opposite side. This strange broken region could be the result of those ancient waves. But here's the catch. If Pluto was completely frozen, the waves wouldn't travel well. They'd fizzle out. For the opposite side to be that damaged, Pluto must have had a soft interior, something able to carry the energy of a deep shock. A liquid ocean fits perfectly. One student researcher, Aidan Denton, tested this idea with computer simulations. Her results matched reality. The kind of terrain we see only forms if Pluto has a liquid ocean about 93 miles below its surface. But the ocean isn't the only thing hiding on Pluto. Scientists found something even stranger. Near Sputnik Planitia, they spotted deep red spots in the ice. That color wasn't normal. It suggested chemical activity, something was reacting or changing. NASA researcher Dale Cruikshank studied the area and found signs of ammonia in the ice. That's a big deal. Ammonia acts like antifreeze. It helps keep water from freezing. And more importantly, it's a key ingredient in chemistry linked to life. Along with methane, it creates the perfect mix for something truly unexpected. When space radiation hits frozen ammonia and methane, it sparks chemical reactions. In laboratories, scientists have recreated these reactions. They found that over time, radiation can transform these simple molecules into complex ones. Some even similar to the building blocks of DNA and RNA. That's right. The very chemicals that helped life begin on Earth could also be forming on Pluto. Slowly. Silently. Over millions of years. If Pluto has an ocean, if it has ammonia and methane, if radiation is doing its work, then something more than chemistry might be happening. The possibility of life, even in its earliest form, suddenly doesn't seem so crazy. Before New Horizons, Pluto was considered a frozen relic. A lifeless world. But now, it could be one of the best places to search for alien life in the entire solar system. All the pieces are there: heat, water, organic molecules, energy. It might not be a place for fish or plants. But microbial life? Chemical processes that mimic biology? Maybe even the early ingredients of life itself? Pluto might be hiding more than just an ocean. But now, scientists are beginning to ask a bold new question. What if life could live on Pluto even if it didn't start there? Imagine something from space landing there, maybe carried by an asteroid or frozen deep inside long ago. Could Pluto's hidden ocean support it? That possibility is why Pluto's story has become so fascinating. One striking clue lies in something unusual, a massive crack that stretches almost all the way around the planet. It's like a giant scar etched into its surface. But unlike Earth, Pluto doesn't have moving tectonic plates. So where did this crack come from? The answer lies beneath Pluto's crust. Deep inside, where there's a hidden ocean, things began to change. As the water below started freezing, it expanded. Ice takes up more space than water, and on a planetary scale, that causes serious pressure. Eventually, the surface couldn't take it anymore and cracked open. That ancient wound still exists today, and it tells us something huge. Pluto might have started warm inside. That warmth may have lasted for billions of years, giving enough time for water and chemistry to interact. And that's how the seeds of life might begin. When NASA's New Horizons spacecraft flew past Pluto, it snapped thousands of pictures. In those images, scientists spotted something they never expected: tall, jagged ice spikes that looked like massive, sharp blades sticking out of the surface. At first, researchers thought these formations were isolated. But when they zoomed out to view the far side of Pluto, they found even more of them. Hundreds, maybe thousands, stretching across the planet's middle like a belt of frozen teeth. These aren't small features either. Some spikes shoot over 1,000 feet into the sky and stretch across more than 20 miles. These ice spikes don't grow randomly. They form in long, straight rows, almost like someone lined them up on purpose. Scientists realize they're made from methane ice, not water. But what's really strange is where they grow, only on high ground like mountain peaks or elevated plateaus. You'll never find them down in the valleys. That tells us something powerful about Pluto's weather. Unlike Earth, where warm air rises and forms clouds, Pluto's atmosphere works backward. The higher up you go, the warmer it gets, so air flows downhill. That means methane gas turns to ice only on the highest, coldest spots. Interestingly, something similar happens on Earth too. In the Andes Mountains, formations called penitents grow in snow, tall, thin blades just a few feet high. But Pluto's version is on a completely different level. Gigantic ice sculptures, taller than skyscrapers, shaped by the wind and sun over millions of years. But that's only part of the story. These spikes connect to Pluto's bizarre seasons. Pluto takes 248 Earth years to orbit the Sun, and every 900,000 years, it tilts dramatically and moves closer to the Sun, triggering what scientists call superseasons. During these superseasons, Pluto doesn't melt, but it changes. Sunlight becomes strong enough to turn solid methane ice straight into gas. This process deepens the valleys and sharpens the spikes, sculpting the landscape dramatically over time. What you end up with is a history of wild weather literally carved into Pluto's surface. The fact that these ice spikes are everywhere shows us that Pluto's climate has always been extreme, erratic, powerful, and more complex than we ever imagined. But even now, many mysteries remain. It's like Pluto is telling us a story in frozen code, and we're only beginning to understand it. Even Pluto's sky adds to the mystery. Back in 1988, scientists watched as Pluto passed in front of a distant star. As the starlight passed through Pluto's thin atmosphere, they detected the chemicals in it: nitrogen, carbon monoxide, and methane. These gases are still there today, even though Pluto's air is 10,000 times thinner than Earth's. Yet it snows, it freezes, and the atmosphere moves. That movement is key. It connects what's happening in the sky to the surface below. Methane gas rises from the ground. Nitrogen sinks into lower areas. Sunlight turns ice into gas, and then gas freezes back into frost again. This cycle keeps going, and it's not just about weather. It affects those massive ice spikes, it may even influence that underground ocean, and it definitely plays a role in the chemistry that's slowly building up on Pluto's surface. From far away, Pluto might seem like a quiet, frozen world. But the truth is, there's far more happening beneath the ice than anyone expected. Even though it's colder than -370 degrees Fahrenheit, something incredible might be hiding there. An underground ocean sealed beneath rock-hard ice, but still partly liquid. And that changes everything we thought we knew about distant frozen worlds. This hidden ocean may be over 100 miles deep and capped by a thick icy shell. At first, scientists assumed it had frozen long ago. But now they believe it might still be at least partly liquid. That's huge. If Pluto can keep an ocean warm this far from the Sun, then maybe other distant planets and moons can do the same. Suddenly, Pluto isn't just some frozen rock. It's the prototype for a new class of planets. Ocean worlds. And Pluto's not alone. It belongs to a family of icy objects beyond Neptune, in a region called the Kuiper Belt. The Kuiper Belt is full of small frozen bodies. Some are irregular chunks, others are spherical like Pluto. For years, scientists dismissed them as leftovers, failed planets that never grew big enough. Too cold, too distant to matter. But Pluto is changing that idea completely. It's only about 1,473 miles across, tiny compared to Earth, but somehow, it's held onto internal heat for over 4 billion years. That means some of Pluto's neighbors might be doing the same. As you see, Santa Cruz scientist Francis Nimmo puts it, if Pluto has radioactive elements like potassium inside it, they could help keep its ocean from freezing. And if Pluto has them, then so might other icy bodies. That would mean oceans under ice aren't rare. They could be normal. That's a huge shift in how we think about life in the universe. For decades, scientists focused on the habitable zone, the area around a star where temperatures are just right for liquid water. Earth is in that zone. Mars used to be. But Pluto? Pluto is way outside. And yet, it might still have liquid water. That tells us that warm environments can exist outside the habitable zone, deep beneath the surface, shielded by thick ice. New Horizons revealed more surprises. One of the biggest was the cracks. These weren't tiny fractures, they were massive. Long, wide, and deep, like veins running across Pluto's frozen skin. And these cracks didn't suggest that Pluto had shrunk. In fact, the opposite had happened. The crust had been pulled apart. That's only possible if the ocean beneath is freezing and expanding, pushing up on the surface as it grows. One especially massive crack begins on the side of Pluto that faces Earth, then wraps around the north, circles down the other side, and nearly makes a full loop around the planet. This isn't just any crack, it's ancient, maybe as old as Pluto itself. And that makes it incredibly important. It gives us a window into Pluto's early history. If this crack formed when the ocean started to freeze, then that tells us the ocean existed right from the beginning. And if Pluto is still cracking today, that means the ocean might still be there, still expanding, still alive in a way. But Pluto doesn't just have water. It has chemistry too. New Horizons captured images of strange red stains on Pluto's surface, long streaks that cross the equator and line crater rims. These red spots aren't rust. They're signs of complex reactions between radiation and ice. When cosmic rays hit ice made of methane and ammonia, they can create new organic compounds. On Earth, we call these compounds tholins. They're not alive, but they're the raw ingredients for life. Tholins can turn into sugars, amino acids, and other molecules essential to biology. DNA and RNA are built from those building blocks. So if Pluto's surface has methane, ammonia, and these red organics, what's in that ocean underneath? And if it's touching Pluto's rocky core, could it be mixing with minerals? Add ammonia into the mix and it gets even more interesting. Ammonia acts like antifreeze. It lowers water's freezing point, helping the ocean stay liquid longer. Combine that with space radiation breaking down surface ice, and you might have a chemical soup dripping down into the ocean over time. That means Pluto's underground sea could be more than just water. It might be full of organic material, mixed minerals, and chemical reactions just waiting to happen. It's not just a cold ocean. It's a rich, strange, possibly active environment that we're only beginning to imagine.